Hi, hello. Uh, this is Preeti. I'm going to take a topic on communication system today. Before going to the topic, let us all know about what is meant by communication. Communication is nothing but just passing on an information from one end to another end. And then the communication system is nothing but uh, an object or an equipment which is used to communicate between the two ends is called as a communication system. Same. The transfer of information from one place to another should be efficient and it should be reliable and secure. A communication is system is a process of conveying information from a source to a destination system. Communication system are the components of the subsystem which is act together to accomplish information transfer or information exchange between with the help of a mean of a signal. Then the rate of information transfer here, amount of information which is to be transferred from a source to destination without any losses is called as a rate of information transfer, which will be determined by the physical form and the technique used to transmit and receive information, and therefore determines the way of a system is designed and constructed. The purity of the signal which is received must be same as the transmitted signal. That is why, which is means whether any losses happened or not. With the help of that only we can able to identify whether any losses happen between the transmission side, that means from the source to the destination side. Then, simplicity of the system. Any communication system must be convenient in order to be effective and efficient and easy to use. And then reliability. Users must be able to depend on the communication system because in the real world they can only able to transfer a data or any other messages from source to destination only use of the communication systems. It must work when needed and transmitted and receive information without errors or with an acceptable error. This is the basic elements of the communication system. First, we just need a input transducer, transmitter, and a channel. The channel is a main thing which is used to pass on an information from a source to a destination one, and the receiver, output transmitter, and then input message. The transducer is nothing but it converts to one form of energy to another form. If we take that means all the systems which can able to convert only a signal into a binary one, that means zeros and one, so it helps any other messages, it may be a data or a voice or a video, which can able to convert into a zeros and ones, that is binary, and then can able to process another equipment, which means another box module. First of all, we are taking an input message. That input message is given to an input transducer. That input transducer forms, which means converts one form of energy into another form, and then that energy is passed on to the transmitter. The transmitter consists of a antenna which is used to pass on the signal from the transmitter to the receiver side. Okay, input. I already told to convert the message to a form suitable for the particular type of a communication system. For an example, a speech waves are converted to a voltage variation by a microphone. Then transmitter process the input signal to produce the transmitted signal that suited the characteristics of the transmission channel. Example, modulation and coding. Channel. I already told channel is a medium that bridges the distance between the sources and the destination. For an example, we can take an atmosphere, that is a wireless medium, that is one of the wireless medium, and then coaxial cable, fiber optic cable, waveguide, these are the wired medium. Okay, the signal undergoes degradation from noise, interference, and distortion. The transmission system can be evaluated according to five main criteria. First one is capacity, and then distance, performance, security, cost, which include installation, operation, and maintenance. These are the five main criteria for evaluating the transmission system. There are two main categories of a channel commonly used. One is line. I already told it is wired. A channel is made up of a metallic cable, such as a coaxial cable, twisted pair, parallel wires, and others, or a fiber optic cable. And then next one, free space or radiated media, that may be an air medium. This is the medium where the transmission of the signal is carried out by the propagation of an electromagnetic wave. The main application are in radio broadcasting, microwaves, and satellite transmission system. And then there is a losses in a medium of a transition. Each medium introduces losses termed as an attenuation distortions and adds noise to some degree to the transmitted signal. The amount of attenuation, distortion, and noise depends on the type of the transmission medium used. There is normally no signal processing in the transmission medium. It is just the medium where the transmitter is connected to the receiver. Then the next module is the receiver to extract the desired signal from the output channel and to convert it form of suitable to the output transducers. Demodulation or decoding technique is happened in the receiver side. Then output transducer which converts again into the original signal. That means converts the electrical signal as its input to form a desired system use. It may be whatever. If we speaks in a microphone, that microphone is your input side, and it will be project in the loudspeaker, that will be your output side. Okay. Then very losses in communication system. I already told there will be three losses: attenuation, distortion and interference. Attenuation is nothing but it reduces the signal strength at the receiver. Distortion, waveform perturbation caused by the imperfect response of the system to the desired signal itself. Equalizer can be used to reduce this effect. Interference, contamination of exogenous signal from human sources, which means interference is nothing but some of the noises can be added according to the signal we have given. And then next noise is loss, random and unpredictable electrical signal from internal or external of the system. The term SNR is nothing but signal to noise ratio, which is used to measure the performance returned to the information analog signal. And then term BER, bit error rate, which is used in digital system to measure the deterioration of the signal. Okay, then the signal can be only two types. One is analog and another one is digital. Analog is a continuous one. Digital is nothing but here we are having an input only two zeros and ones. Analog, I already told, it is a continuous variation, assumes the total range of frequency or time. All the information is transmitted. Digital take the samples non-continuous and the translates two ones and zeros. Digital communication system advantage, which is inexpensive, privacy preserved, data encrypted, can merge different data's error correction. And then disadvantages, it have a larger bandwidth, synchronization problem is relatively difficult. Analog communication system disadvantages is it is very expensive, no privacy data is preserved, cannot merge different data, and no error correction capability. Advantages, it has a smaller bandwidth and the synchronization problem is relatively easier. Then baseband signal. Baseband signal is the modulating signal either in digital and analog form in communication system. That means the transmission of original information, whether it may be an analog or digital, directly into a transmission medium is called baseband transmission. That means without the help of the transducer, we are using a signal to pass on from input to the transmission side. Then modulated signal. Modulated signal is a baseband signal which its original frequency is shifted to a higher frequency to facilitate the transmission purpose. This is a baseband signal, the modulation process. That means a original signal is given to the modulator and a carrier signal is added. Carrier signal is added with that original signal. That means amplitude of the carrier signal is added with that and it forms a modulated signal. See, listen, as I already told, modulation, the process of changing a baseband signal to facilitate the transmission medium. The process of modulation is frequency translation, such as amplitude modulation, frequency modulation, and phase modulation. Sampling and coding, such as PAM, pulse amplitude modulation, pulse code modulation, etc. Keying, such as amplitude shift keying, phase shift keying, and the frequency shift keying. Okay, now we are going to see a detailed process of modulation, operation of varying amplitude, frequency, or phase of the carrier signal accordingly in with the amplitude of the message signal is called modulation. So listen, this is your basic block diagram. A baseband signal, that is an input signal that is coming under modulated signal, or a oscillator which is used to produce an carrier signal, that is both get integrated and then give an modulated signal. Then need for modulation. Why we need a modulation technique? That is the main thing we want to know, why we need a need of modulation. To transmit a voice signal, a large size antenna is required. To antenna length is proportional to half of wavelength. The size of the antenna will be more than the distance between the transmitter and receiver. Again, when more than one transmitter is involved, all station will overlap in one frequency band. For those above reasons, we choose a carrier which is a high frequency radio wave, can travel long distance without attenuation, and as the frequency is high, smaller antenna is required. Selecting different carrier frequency for different transmitting station can eliminate overlapping of frequency band. See, this is the modulation technique. Source encoder, channel encoder, modulated, and it passes to a channel demodulator, channel decoder, source decoder, and destination. To modify a signal, and then we need a modulator. To detect the modification, we need a demodulator. See, this is the basic classification of a modulation. Types of modulation: continuous wave modulation and the pulse digital modulation. Continuous wave modulation consists of an amplitude modulation and angular modulation. Angular modulation is again divided into a frequency modulation and phase modulation. Pulse digital modulation is divided into digital modulation and analog modulation. Digital modulation consists of a pulse code modulation, and analog modulation consists of pulse amplitude modulation, pulse duration modulation, and pulse position modulation. First, analog modulation. We want to know what is analog modulation. If the variation in the parameter of the carrier is continuous in accordance to the input analog signal, the modulation technique is termed as an analog modulation scheme. It is classified as an amplitude modulation, frequency modulation, and phase modulation. Then digital modulation. If the variation in the parameter of the carrier is discrete, then it is termed as a digital modulation technique. It is classified as amplitude shift keying, frequency shift keying, and phase shift keying. First of all, we want to know the amplitude modulation, that is AM. It is the process of varying an instantaneous amplitude of the carrier signal accordingly with the instantaneous amplitude of the message signal. Here, I'm going to consider a message signal as a M of t and C, carrier signal, as C of t. Okay, see, C of t can be written as A cos omega ct. Then AM signal F of t can be written as, here I'm going to add C of t plus M of t. Okay, M of t can be written as M of t into cos omega ct. Okay, then which means total frequency, that means F of t can be written as M of t plus C of t. Here M of t can be considered as A cos sorry, m of t into cos omega ct, and c of t can be considered as a cos omega ct. Then substitute that, then given f of t is equal to a plus m of t into cos omega ct. See, let us take a diagram. That is a modulating wave, that is our message signal. Then we are adding a carrier signal to that. Then while adding the carrier signal to the message signal, the signal can be changed, the minimum level of an modulating. See, during the negative cycle, it is a minimum level of a modulating waveform corresponds to the minimum of an RF envelope. And while the high wave, that is the positive high frequency, positive amplitude it reaches, that is your high frequency envelope. Okay, now this is your waveform of an amplitude modulation. Then the frequency spectrum of the modulation, while deriving it, we can able to find the frequency spectrum. First of all, we have to take the frequency spectrum, that is fc, that is carrier frequency, and then the lower band and the upper band can be returned using the message signal and the carrier signal. Fc plus fm can be written as an upper side of the frequency modulation, sorry, upper side of the amplitude modulation, and then lower side band can be written as fc minus fm. The frequency spectrum of the AM comprises of a lower side band whose highest frequency component is present at fc minus fm, and an upper side band whose highest frequency component is present at fc plus fm. The carrier frequency fc. Okay, this type of amplitude modulation is known as a double side band full carrier, DSB FC modulation. Double side band full carrier, that is DSBFC. This is a standard amplitude modulation used for broadcasting. Here the carrier conveys no information. Here the carriers conveys no information. Modulated wave wave envelope has same frequency as information signal. The amplitude of the modulated wave varies according to the amplitude of an information signal. Then before we have seen about full carrier, then now we are going to see about double sideband suppressed carrier. In this type, a carrier wave is absent. All the transmitted power is obtained only in lower sidebands and US, which means upper sidebands. Here, frequency produced by an AM are symmetrically spaced above and below the carrier frequency, and the carrier level is reduced to the lowest practical level, ideally being completely suppressed. Sideband, single sideband. This means SSB is either an upper sideband or in the lower sideband, contains the complete information of the message. Only at the one sideband is necessary for the information transmission. When only one sideband is transmitted, the modulation is called as a single sideband. Vestigial sideband, VSB. The limitations of a single sideband modulation being used for voice signal and not available for video or TV signals leads to the usage of vestigial sideband. Sideband is a sideband that has been only partly cut off or suppressed, which is mainly used in the radio communication. Then we are moving to the frequency modulation. Frequency modulation is the process of varying the instantaneous frequency of carrier signal accordingly with the instantaneous amplitude of the message signal. As usual, m of t is the message signal and c of t is equal to a cos omega ct. Then fm signal will be f of t is equal to a cos omega ct plus kf del integral m alpha into d alpha. See, listen, the waveform, a message signal, the carrier signal. Okay. Here, when the frequency is high, see, actually we already know f is equal to 1 by t. Then that means there is an inversely proportional. The time is inversely proportional to the frequency. When the frequency increases, the time decreases. When the time increases, frequency decreases. The same process has happened while seal the information message. This is your carrier signal. While when the information signals increases, that means a time period increases for that. At that time, your carrier frequency gets shrinks. Okay. The FM wave is comprised of an infinite number of side components. A bandwidth of an FM signal must be wider than that of the amplitude signal, that is amplitude AM signal. As a modulation index increases from MF equal to 0, the spectral energy shifts from the carrier frequency to an increasing number of significant sidebands. The higher the modulation index, the greater than the required system bandwidth. The BW is equal to 2 into N into FM, where N is the highest number of significant sideband components and FM is the highest modulation frequency. BW is equal to 2 into del plus FM, which is equal to 2 FM into 1 plus MF. Narrowband frequency modulation. NBFM uses a low modulation index value with a much smaller range of a modulation index across all values of the modulating signal. Then narrowband frequency modulation system restricts the modulating signal to the minimum acceptable value, which is 300 hertz to 3 kilohertz for an intelligible voice, used in police, fire, and taxi radios, GSM, attenuated radio, etc. Wideband frequency modulation. When better signal quality is required, wideband FM is used at the expense of the greater spectrum usage. The term WBFM is used in application whether the modulation index is equal to or larger than 1. In such applications, spectral frequency is less important and sometimes a large spectral band is actually desired. Phase modulation. PM is the process of varying the instantaneous phase of the carrier signal accordingly with the instantaneous amplitude of the message signal. Thus, if M of t is the message signal and C of t is equal to A cos omega ct, then PM signal will be F of t is equal to A cos omega ct plus Kp M of t. So listen, while the phase change, this is your carrier. First of all, we are having a carrier signal, then modulating signal. At the point where the phase gets changed, okay, at the point where the phase change, the carrier signal's frequencies also, phase can also be changed. Digital modulation. See, listen, one digital signal carrier signal. ASK, amplitude shift keying means whenever a 0 comes, there will not be a signal. That is represented here. Then FSK changes the carrier frequency. See, listen, when it is 0, that means the time is 0. At that time, your frequency gets increases. Okay, then the phase shift keying, when the phase changes, it gets changes. While one, it starts with in the positive side, while it is 0, the phase gets changed to 180 degree. Okay. Amplitude shift keying. In the amplitude shift keying, the amplitude of the signal is changed in response to the information. Change in response to the information and the frequency and the phase is kept fixed. Bit 1 is transmitted by a signal of one particular amplitude. To transmit 0, we can change the amplitude keeping this frequency constant. As I already told, see, listen, this is your carrier signal and the modulating signal is 10101010. When it is 1, the free carrier signal, which means the modulating signal keeps the same carrier signal. When it is 0, it just shuts the frequency. Then the frequency shift keying, when data are transmitted by varying frequency of the carrier, we have the case of frequency shift key. In this modulation, carrier has two predefined frequency, WC1 and WC2. When the information bit is 1, carrier with WC1 is transmitted, that is cos omega C1, and when information bit is 0, carrier with WC0 is transmitted, that is cos omega C0. See, listen, this is your carrier signal. As of all, we are taking a modulating signal 10101010. See, listen, when it is 1, it directly passes the same carrier signal. When it is 0, at that time your frequency get shrinks because there is no time period. That is 0 at that time. At that time your frequency get shrinks. Then phase shift keying, the phase of the carrier is shifted for this modulation. If the baseband signal m of t is equal to 1, the carrier in phase is transmitted. If m of t is equal to 0, carrier without of phase is transmitted. In in PSK, that is in phase shift keying, we change the phase of the sinusoidal carrier to indicate information. Phase in the context is the starting angle at which the sinusoidal starts. See, listen, the same carrier signal we haven't taken, the modulating signal 10101010 we haven't taken. See, listen, when it is 1, it moves in the positive direction. That means in the positive phase, 0 phase. Okay, that just take it as a positive way. Okay, and then when it is 0, the phase gets changed to 180 degree. Abruptly it changed. These are the various types of phase shift keying: binary phase shift keying, quadrature phase shift keying, 8-point phase shift keying, 16-point phase shift keying, quadrature amplitude modulation, 16-point quadrature amplitude modulation, 64-point quadrature amplitude modulation, differential phase shift keying, minimum shift keying, and Gaussian filter minimum shift keying. These are the techniques how to predict the type of phase shift keying. That's all about the basics of both the communication system and modulation. If you have any queries, you can ask me.